All right, here begins our videos for Chapter 8. And Chapter 8, we're going to start with talking about electron configurations. So your periodic table is divided up into sections. Okay, your first two columns on the left, the alkali metals and the alkali earth metals, comprise the S block. Your transition metals comprise your D block. And your non-metals and the far right corner of your metals make up the P block. And you'll see in the upper right hand corner you see a special red 1s2, that's helium. Helium really ought to live over in the S block, but because it's a noble gas, that's why it sits over there on the top. And then your lanthanides and actinides are your F block. And what's important to realize is that the F block actually lives right here, right at the beginning of your D block. Okay, so when we get to those rows, you have to remember to insert the F block in that space of the periodic table. So doing electron configurations is actually a very simple process. What you want to do is read the periodic table like a book. And if I could spell, so we're going to read the table top to bottom, left to right, just like we were reading a novel or a textbook, and list things as they are full. List things as they fill. Boy, I can't spell this morning. All right, so just as a reminder, so s orbitals, right? We have one s orbital, it's a sphere, right? So each orbital can hold 2 electrons. So when we have an s2, that denotes that superscript 2, that's not a squared, that's a number, that's a counting number. So when we have 2 electrons in the s orbital, that is a full s. Okay, so when we are reading left to right, when we get to an S2, we're going to write it down. Okay. P's, remember we have 3 orbitals in the P's, and each orbital can hold 2, so that means a total of 6. So this superscript 6 tells us that there are 6 electrons in our P orbitals. That's a full P. So whenever we get a P6, we're going to list that. All right, D's, there are 10. 5 orbitals, 2 electrons each. So when we get a D10, we're going to list a full D. And F's, there are 7 orbitals in the F block, or 7 shapes to the F orbitals. Each orbital can hold 2, so there's a maximum of 14 for the F's. So when we get an F14, we're going to list a full F. Okay, so let's take a look at a slightly more detailed periodic table. Okay, better than my drawing. And I'm going to, in red, circle or highlight helium up here because it really should be 1s2, okay, instead of in the P block. All right, so electron configurations are very much like street addresses. Okay, so if I find a particular element, where it lives on the periodic table, it has a particular number. It's 1s1, or it's 2p1, or it's 2p4, or something like that. And then everything that comes before it is sort of like the street name, okay? And then where its actual location is kind of like the house number. All right, so hydrogen is the very first element. Okay, so there's nothing that comes before it. So hydrogen's electron address, or electron configuration, it's in row 1, first column of the F block. So I'm going to say 1 S superscript 1. All right, and if I keep reading left to right, go straight across all the way to helium, helium really should be in the S block. So it's still in row 1, but it's S2. Okay, helium really ought to live right here in the second column of the S block. All right, but it lives over here on the far right of the table because it's a noble gas. All right. So let's do some more. The best way to get our brains wrapped around electron configurations is to do a variety of problems. Right, so let's do lithium. Let's do the electron configuration for lithium. Okay, so I'm going to start in the upper left-hand corner of the periodic table, and I'm at 1s1 with hydrogen, and I'm going to read across until I get 1s2. Okay, when I have an S2, I list it. So I say 1s2. Now I go to the next line, and the next line is where lithium lives, and lithium's address, its house number, is at 2s1. It's in the first column of row 2. All right, so let's do a few more. Let's try boron. Okay, boron lives over here in the P block. All right, so I'm going to start in my upper left-hand corner. I'm going to say 1s1 with hydrogen. I come reading left to right. I get to the 1s2. Whenever I get an s2, I list it. Now I'm going to come to the next row. All right, now I'm in row 2. I'm going to read left to right. I go 2s1, 2s2. When I get to the end of the s's, I list it. So 2s2 goes in the list. Then I'm going to continue straight across, and I get to boron, and boron lives at 2p, still in row 2, first column of the P block. All right, next one on our agenda to try out is magnesium. All right, so I say start at hydrogen, I go 1s1 to 1s2, and I list it. Now I go row 2, and I go 2s1, and I get to the end of that bit, and I go 2s2. When it's full, it's s2. And then I continue reading across, I get to the P block. So I'm in 2p, and I'm all the way to the end, and I get a 2p6. When I get p6s, I list them. Okay, now I get to the row that magnesium actually lives in. We're in row 3, and magnesium lives second column of the S block in row 3. Right, so I'm reading left to right, top to bottom, until I get to the element that I'm trying to find. And then I list things as they become full. So S2s, P6s, D10s, F14s. Right, so let's look at argon. Argon's over here, it's a noble gas. Right, so 1s1 at hydrogen, all the way over to 1s2. S2s, I list them. Now I'm in the next row, row 2, and I go 2s1 to 2s2 at the end of the line. Okay, and I continue to read across left to right. When I get to the end of the line, 2p6, and I list it. Now I'm in row 3, and I go 3s1, and I get to the end of the line at 3s2. And I keep reading until I get to argon. And argon is in column 6 of the P block, 3p6. All right, so let's do one more, and then we'll talk about a slightly easier way to do this. But it's important to have the foundations. So let's do, for example, germanium. All right, so we're gonna do the same tactic, reading top to bottom, left to right. So 1s1 over to 1s2, and I list the s2. Now row 2, and I go 2s1 to 2s2. I read across, and I end the line at 2p6. Now I'm in the next line at row 3, and I get to the end of that bit at 3s2, and I keep reading left to right until I get to the end of the line at 3p6. Now I'm at row 4, and I get to the end of the line at 4s2. Now when I hit the D block, I have to drop down a number. Okay, so I'm in row 4, but when I hit the D, it drops down a number to 3D. Okay, so I'm at 3D1 at scandium, and I read across, and when I get to D10, I list it. All right, and then I'm at 4p, so when I get back to the p's, I go up to 4, and germanium lives at 4p2. All right, so as you can see, as we get farther and farther down the table, things get longer and longer and longer, right? So thankfully, we have a easier way to write these, right? It's a condensed version, sort of like a shorthand, right? So let's think about what we have written here with germanium, right? So up to 3p6, okay, what element lives at 3p6? That's argon. Okay, so argon lives at 3p6. And so this entire piece right here, up to 3p6, that's just argon. Okay, so I can list the noble gas as sort of a shorthand that tells me everything in the row before the element that I'm after. And so I can write that as sort of a shorthand. So I can say argon 4s2, 3d10, 4p2. Okay, so all I have to do is find the noble gas in the row above it, and then list the things that are in the same row as the element that I'm after. All right, so let's do another example. All right, so let's do calcium. All right, calcium's down here on the left. So what I'm going to do is find the noble gas in the row above it. Okay, and that happens to be argon. So I list argon, and I have to put it in brackets. And then I just list everything in the row that calcium's in which case it's just 4s2. All right, now, the argon part we're going to refer to as core electrons. Right? And the S2, those 2 electrons in that 4s, those are valence electrons, or outside electrons. All right, I'm going to go ahead and stop this video right here, and we'll pick it up with a little bit more on noble gas configuration, electron configurations.